In this video, I'm going to show you how we turn binary numbers into hexadecimal numbers. Now, first of all, a quick reminder of what hexadecimal is. Hexadecimal is the base 16 counting system, and that means we have 16 numerals that we use to count with in our units column. In the decimal system, we have 9 units in our counting system, and then we add a column and we start all over again, and so we can go up down our numbers like so, up from 10, 15. So we stop at 9. Now the hexadecimal keeps going, but we don't have any numbers as our numerals. What we do have are letters. So A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. And that's our 16th numeral, because our first numeral is the number 0. We start counting at 0 as our first, so we go through there. So that's hexadecimal. So to convert a binary number to hexadecimal, we first convert it to decimal, but we do something smarter to it first, and that's because there's a bit of magic that goes on between binary and hexadecimal. Now, if you remember, with 4 bits, that's 4 characters, you actually get 16 combinations that you can have. So 0, 0, 1 all the way down to 1, 1, 1, 1. Now, if we look at how we represent numbers using those, we put a unit, a 2, a 4, and an 8. So these are our columns for doing maths, and we can see that this number is decimal number would be 0, and this decimal number would be 8 plus 4 plus 2, that's 14, plus 1, that's 15. And 15 in decimal is equivalent to hexadecimal F. So 4 bits allows us to do a direct conversion, more or less, into hexadecimal. So when we get bigger numbers, all we need to do is start chunking them into these 4 bits. Now 4 bits make a nibble, so we can start chunking. So if I had a number like 1, 0, 1, 1, 0, 1, 1, 0 in base 2. To convert that to hexadecimal, I chop it up into 2 nibbles. So I count 1, 2, 3, 4, 1, 2, 3, 4. So I've now got 2 halves to work out. So this one, 1, 2, 4, 8, and this one, 1, 2, 4, 8. 4 add 2 is 6, so that becomes decimal 6. This one is 8 plus 2, that's 10 plus 1, that's 11. So I then look up those in my table. 6 is obviously 6, and 11 is B. And so that is B6 in base 16. It's the same number as this, which is 1, 0, 1, 1, 0, 1, 1, 0. Okay, so that's how we do the calculation. And if we've got a longer number, so say there were even more bits over here, then again we just split that off into nibbles, and we keep stringing them together to get the hexadecimal conversion. And if I want to work backwards, I just do the same thing. I split up the columns, and for each column I work out the decimal equivalent, and then I work out the binary equivalent. So that's how we turn binary into hexadecimal.